All right, so let's take a look here at this problem number 5. We have a trigonometric equation, involves sine. Um, we expect that there might be infinitely many solutions to this, but we're only looking of those infinitely many for the ones that are between 0 and 2 pi. Now, it's possible this could have no solution, but let's jump in and take a look at this a little bit closer. Let's get this sine by itself. So in 2 steps, we'll subtract 4 from each side and then divide by -3. So we can have the sine of 2 theta is equal to 2 minus 4 is -2, but when -2 is divided by +3, we have 2/3. Now, if we go look to the unit circle, we're not going to see 2/3 as a y-coordinate, so we'll have to use the calculator. We do know that there exists a point on the unit circle that has a y-coordinate of 2/3. It's just not one of our special angles that we have that we know the exact values for. So 2/3 is going to be some point here in quadrant 1 and some point here in quadrant 2, where this angle is the angle of interest, and then this angle is also an angle of interest, because that'll satisfy any angles that are coterminal to those two angles will also satisfy this equation. So the calculator, however, is not going to help us with this quadrant 2 angle. When we go to use the inverse sine, the calculator is only going to use the right half of the unit circle. So let's see what that calculator would give us. And it says to round to the nearest thousandth. So let's also let the calculator do that for us as well. So we're definitely in radian measure. We've fixed the calculator round to 3 decimals. Let's take the inverse sine of 2/3. So this angle of 2 theta is approximately equal to 0.730, and any angle that is coterminal to that. So we'll add 2 pi n. Now, we need to figure out the angle over here in quadrant 2, and the calculator is not real helpful there. But this 0.73, we can use that as a reference angle. And so if we want this angle, we can just take pi minus this 0.73, and then we'll take any angle that's coterminal to that. So we've got that value in the calculator there. So if we just take second pi minus our previous answer, we get 2.412. 2.412. So to get this theta by itself, let's divide everything by 2. If we've got 0.73 divided by 2, 0.365. And if we divide this by 2, what do we get? If we have this 2.412, 1.206, so that describes the infinitely many solutions that this equation has. We don't want infinitely many, we just simply want the ones that are between 0 and 2 pi. And it has a decimal. as a decimal, 2 pi is approximately 6.28. All right, so let's come over here and construct a table for these various values of n. If we let n be -1, then we're going to be less than 0, and we don't want that, so we're going to start out at 0. Our variable this time, they're using this Greek letter theta. We'll let 1 be the first equation and theta 2 be the second equation. So if we let n equal 0, we're saying that 0.365 is an approximate solution to this equation, and that solution is between 0 and 2 pi. For the other one, 1.206. If we let n be 1, then what do we have? We've got this 0.365 plus pi, and that's 3.507, or approximately. All right, so what about if we go back and use that 1.206 and add pi to it? 4.348. 4.348. So all of these so far are solutions to our equation, but they're also between 0 and 6.28, between 0 and 2 pi. If we let it be 2, that's going to be 2 pi plus something, so it's definitely going to be bigger than 2 pi. So this guy, this angle will be too big. Well, if we let n be 2 over here, it's the same reasoning. You've got 2 pi plus some amount, and that's going to be bigger than 6.28, so that's too big as well. So I believe that those 4 are our solutions. Let's check and see if they're reasonable. If we plug them into our equation, we should get on the right-hand side a number that's approximately 2. So we're still in radian measure. We've got 4 minus 3 times the sine, 2 times our angle. So let's check this 0.365. See if this is a number close to 2. I'd say that's close enough to 2 for us. All right, so let's check. Let's bring up our last entry. And let's change that to 206. Hey, that one's even close. That's 2. So let's bring up our last entry. Change this to 3.507. And it's still pretty close to 2. If we change this to 4.348, slightly over 2, but hey, that's fine. So all of those solutions check. All of those, and they're between 0 and 6.28. So let's just highlight. I don't want to write it again. These guys right here are 4 solutions, and the 2 there in front of there was a horizontal shrink, so we were expecting the possibility of more than the 2 solutions you normally get when you have one complete revolution because of the horizontal shrink. All right, I'll talk to you later. Bye. Hope that helped.